many dimensions? 2. I've got one thing moving in the x direction, another thing moving in the y direction. If they collide, if I'm really mean-spirited, right, I might get some weird collision like this. How might I characterize this collision? As what kind, possibly? It could be elastic if they're like really super hard, like billiard balls or something, where the kinetic energy would be conserved, right? This would be a really hard problem, by the way. This one would be a really hard problem because this guy gives all of the x momentum, but after collision there's some x momentum here, but this one also has some x momentum, doesn't it? But the point is this momentum plus that one has to equal that total. Yes? Likewise, this guy gives all the y momentum of the system, and this guy has some y momentum after collision, and this guy has some y momentum after collision. That plus that would have to equal that. And then you've got angles in here and nasty trig and all kinds of stuff going on. It got quiet all of a sudden.
Find the nasty trig.
It got quiet, didn't it?
Yes.
Okay. So that would be the mean-spirited approach.
But that's not what's on the final.
Is that a question or a statement?
A little bit of both.
You're supposed to say a statement, right? It is, in fact, the mean-spirited approach. What would be the Santa Claus
What?
approach to the final exam?
Completely inelastic.
You all get 100.
Say that louder, Stefan.
Completely inelastic.
Oh, completely inelastic. What might happen in that collision?
They stick together.
They stick together and they move off at common velocity, correct? They have to, they're stuck together. So we've got a blob off like that.
Oh.
Roughly, right?
Yeah.
I mean, doesn't that make sense? Okay. So how do I want somebody, I'm not going to do it, I want somebody to tell me how to set this up. I better well see 2 equations because how many dimensions are we dealing with?
2.
2. X and Y. So who wants to help? Here, I'll get you started. Let me call this M1, and let me call this M2. I'll
Would it
help you guys.
be M1V equals M2V? That doesn't.
Nope. Which side of the equation are you on? Before or after? What equals? All right, guys. Hey, what do we know about momentum in all cases? Linear momentum. It is conserved. No matter what kind of collision, it's conserved. What isn't necessarily conserved is the energy side of it, right? Elastic energy is conserved. Inelastic or completely inelastic energy is not conserved. But linear momentum is always conserved. Always. So what do I start with in the x direction? No, what do I start with? M1, V1, original, right? It's already all in the x direction, right? How much x momentum does this have?
0.
Right, plus 0 equals, so right after collision, this is the little bit tricky part. Tell me what to do.
M1 plus M2 times.
Okay, so they stuck together. Now be careful. Say again? V final x component, right? V final x component. This is V final, the whole thing, but this is the only piece in the x direction. You guys tracking? So this is not this. This velocity is that. Yes? Okay. Now what? Now the y direction. How much of this is in the y direction? 0 plus m2 v2 original You guys understand? Now, sometimes this is enough to solve the problem. If you happen to be given this or that, because I could plug in, if I know that, I can solve some stuff. Sometimes it's not enough, so we need to maybe extend this a little bit. So it won't change the setup. I'm interested in the x component of the final velocity, which is this guy. I'm going to need to multiply by cosine, right? And then in the y dimension, I've got m2 v2 original v final sine theta, right? Notice I'm taking the hypotenuse times some trig function. This represents VFX. This represents VFX. You see how I did that? So if I had to solve this for the angle or the final velocity like this, I can actually, you've seen my trick where I divide equations, right? Is that a oh yeah facetiously or oh yeah I remember?
Oh yeah, I remember.
Is that true?
Why would I lie to you?
I don't know. People do.
That's untrue.
So realize if I divide this equation by that equation, this divided by that, this cancels, right? That cancels. And I get tangent of theta, sine over cosine is tangent, equals this, right? And that would allow me to find theta with inverse tangent, if I knew these numbers. So I could find theta. And once I know theta, then I can plug in here and solve for V final in either one of these. It's just like two equations and two unknowns. Once I know one of them, I can end up plugging in to find the second piece I'm looking for. Okay? There are no numbers there, but if you write this down and think about it, once again, I urge you not to simply write it down and not think about it, but maybe go back and start from scratch. There are examples in the book that you might, and listen, I'm telling you exactly the problem type. So don't go look at examples that aren't like these. Look at examples that are exactly like these and study those. And we've done some in class and so on.